Yes, I also need to describe it. Yeah, it's a big room. Looking for volunteers to scribe. Oh, thanks. I think one may do for today. Oh. Whatever form is best for you. Etherpad thing? I don't care. I realize now we're starting fairly late. Apologies to everyone for that. This is Captive Portals working group. If you're in the wrong room, then stay, because we have plenty of room. I believe I'm obliged to show this slide. I don't know that anyone has ever read this slide when it's been shown. So I'm helping. I have no idea whether this is correct or not. I just used Google Translate for this. What? Oh, that's an interesting question. Is it? I have no idea. There were a few issues that I just wanted to clear up before we get into the agenda. So the first thing is we have a new area director. He's wearing the hat. There's a lot of people in here who aren't perhaps accustomed to working in the apps area. Welcome. So Adam here is now looking after this working group, I guess, in the very abstract sense that an area director does. We've been having some discussions about finding an occupant for the seat sitting beside me. We expect to have some sort of resolution to that relatively soon, I hope. They're weird, aren't they? Especially sitting here. We also have an outgoing area director. I don't think she's in the room, so I will pass the records on to her later. Okay. We have a fairly open agenda this time. I'm giving 15 minutes to each of the people who asked for time. Please try to keep on timer. Deal with that. Is there any bashing that anyone would like to do to this agenda? New items, people think they're going to take less time. You're not allowed to take more time. Okay. Rico, who is there? Yes.
So, hi, I'm Mariko Kobayashi from Japan, and I'm from Keio University. And I have a presentation about survey on behavior as a captive portal. And this time I conducted a survey, especially focusing on Japan. So next slide, please. So in the previous IETF, IETF98 so we have a captive portal launch buff. It is not official thing, but we have a lot of discussion about 40 minutes. And so we discussed the necessity of the industry survey for captive portals. So that's why I implemented that survey tool to automate the survey on my Raspberry Pi and use it for this time. And then this time I show an actual survey about a captive portal in Tokyo, Japan. So next slide, please. So this is survey overview, and I conducted survey on behaviors of about 40 captive portals in central area of Tokyo, Japan. And here's survey items. And the first one is false negatives. Like I'll try to check the iOS Apple's captive portal detection strategy, and also Windows strategy, and the Android one. And the second one is HTTP status code. I will explain later. And the third one is DNS poisoning. So next slide, please. If you're an Apple engineer at Apple or Google, please let me know the more correct information. But I survey on the web page, a lot of web pages, and here it's some basic strategy of Apple on the Windows and Android. And the first one is Apple's one, and the terminal access some well-known web pages like captive.upload.com and to check the internet connectivity. And if they get the success, there is for internet connection. But if they get the other response, it is regarded as a captive portal. And the second one is Windows, and the Windows have two steps to check the captive portal. And the one is they send a DNS lookup request for the domain, and they check whether they get the correct IP address, the one, and and the second one is they also access that well-known web page and whether they can get the correct package or not. And the third one is Android strategy, and they have also well-known web pages for HTTP proof and HTTPS proof, and that web page is just the sponsor 204 and no content. So if they get that response, there is free internet connectivity. But if they cannot get that response, they're in behind the captive portal. The next slide, please. And okay, so first one is false negative. So macOS and iOS, the strategy. And for this strategy, I could detect about 90% of captive portal, but less than 10% the strategy could not detect. This next slide, please. So next one is false negative. So Windows strategy, and as I explained in the previous slides, Windows strategy has two steps to detect the captive portal, and so this is the result. And about 10% of captive portal defeat the Windows detection strategy. So not so many, but the Windows strategy also cannot all of captive portal in Tokyo in Japan. So next slide, please. So this is I think this is the most interesting information for you. And this is false negatives for Android in the strategy. And the left one is the graph for checking HTTP proof, and the right one is for checking HTTPS proof. And as you know, most of HTTPS proof does not success on captive portal. And okay, so so for HTTP proof, 1/3 of captive portal defeat the detection strategy, and they reply to for and no content to unrevealed web pages. So it means this is not captive portal, but actually they are captive portal. So the Android cannot detect the 1/3 of captive portal as a result. So next slide, please. So this status codes means I analyzed the returned HTTP status code when my survey toolkit access the well-known web pages of iOS or macOS and Windows or Android. And the result data repeats following results. And the current proposal is Mark Nottingham has some HTTP status code proposal, but actual the status code currently I got the 302 and 307 and 200. And my prediction was 302 or 307, but actually there are a lot of 200 status code. So next slide, please. So I also surveyed the DNS poisoning, but most of the captive portal did not do DNS poisoning for this time. And I also checked the setting of public DNS for my toolkit, and most of flows failed when I set public DNS like 880 for my survey toolkit. So next slide, please. So as a result, can say there's two types of behaviors of captive portal, and this is expected behavior of captive portal, I think. And I think this is most standard one, and most of operating system can detect this type of a captive portal, and they reply with either 302 or 307 with a redirection URL. So I think this is the good type of captive portal. But the next slide, please. So this is the problem, and this is unexpected behavior because of captive portal, and some of captive portal which responds 200 as a HTTP status code defeat the detection strategy. And moreover, some of them also, like as I said, defeat the Android detection strategy. And all of this model of captive portal deployed and operated by the same network service provider in Japan. So they have some reason to defeat the captive portal, I think.
Question?
So next slide, please.
Question.
Okay.
Question. So I could have sworn that we wrote code in 2014 that does this, that detects 200s, and it presents that as a login page. What actual Android device did you test?
What?
Which Android device did you test on?
I'm sorry. For the survey.
Yeah.
Yes. Okay. As I said in the second or third slides, I conduct this. I implement this survey toolkit on Raspberry Pi, and I set some user agent, but not connected on actual Android. But I also test some.
So you reverse engineered our implementation, then you ran it.
Okay.
I see. So you tried to figure out what our code does, and then you ran it.
Yeah. Yes. But
sorry. Okay.
Yeah. Okay. So for this model, I use my Nexus and test it also on my actual device, and they cannot detect. Okay.
So I think the assertion here is that this particular network service provider is spoofing the 204, not the 200. And so they're producing the same response that your servers are producing.
Thank you. So the next slide, please. So why network service provider to try to defeat captive portal detection is, I think, biggest problem for us. And currently, I asked the network service provider. I asked the technical manager of network service provider, but I cannot get the answer yet. But this is my prediction. But like originally, the captive portal detection is deployed for the protection of users' privacy, like to use incognito window, and like they cannot get users' cookies or something like. And so incognito window has some trouble with login process or API, and the users complain about the detection is one of the reason. Or some network service provider want to get some information from user's browser. I'm not sure, but for marketing or business reason. And I'm not sure, but only Japanese network service provider defeat for some conservative reason. How about other countries? So next slide, please. Okay.
Yeah, definitely not just Japanese. I've seen it in other places.
All right, thank you.
Yeah, so the suggestion here is that this is not necessarily representative, but it's informative.
Okay. So why captive portal deployed is the I think in IETF 95 someone presented about this, and they use for authentication or payment information, advertisement notification, or sometimes for business marketing for tourists. And so some located owner want to use as email address or ID or credit card info number of that cookie or user agent. So it is up to its location owner. But if they defeat the captive portal detection, the network service provider cannot provide their service correctly, I think. So next slide, please. So, and my proposal is writing captive portal survey ID will be variable output for us. And this time I conducted just only in Japan, but conducted a further survey like in other countries, like Asia or other US or Latin America or also some Europe, will be good, I think. And for that, I want to focus on some main city in other countries. And now my plan is implement some captive portal survey app or Android app or some other way. Yeah, if you have any proposal, please let me know. And the next slide, please. So my discussion is the captive portal detection does not work correctly in Japan actually, and the network service providers cannot provide their service also. And so we need to cooperate with network service providers, not only OS vendors. It is important to meet their demands for our captive portal solution. Like if we make some protocol or some new solution, but if network service provider defeat it, it does not make sense. That's why. And any opinion or ideas for my survey proposal or any survey ideas, please let me know. That's it. Thank you.
Lorenzo Colletti. Yeah, I think this is good information. I think the part of the problem is that the Android code is changing all the time, and right now it does more than two checks, and we change the host name various times. So one thing that would be great is if you need an actual Android device, I will give you one, and so you can actually run the code on a real device, because those two probes are very different. Also, part of the goal of this one is to ensure that the user, even if the captive portal is not cooperating, that the user still keeps working internet access. And so doing SSL is kind of that 76% is that's the goal of that one. Right? So there's, I agree that we need to work with these people, and if you know who they are, I'm happy to chat with them. Particularly if you know the Japanese ones, we can talk to them.
Yeah, thank you.
So yeah, so do you want an Android device? Like, can you use actual hardware? Because I think it would be much more useful. Or you can actually re-implement the real code that we have, because you can read that code, because it doesn't just do two things; it does three things now, and it has a staggered timer. And then if the SSL probe doesn't succeed, it decides to do some other thing, right? So yeah, so or we can work together on that.
Okay, and for Android detection strategy, I saw some code like can I go to the 16 page?
Which one?
Yeah, 16 page. Yes, that's one. And there's some Googlers give me that links, like I think network monitor.java, like something. But I'm not sure that. Yeah.
That's the correct code.
It is not the newest version.
Yeah, it's not. So sorry, no, that is the right link.
Right link.
But
okay.
What you described in your earlier slide is not what the code does for a few months now. So.
Yes. Actually, it's like too confusing to catch up all of things. So I may cut off something like.
Tommy Pauly, Apple. So first of all, thank you so much for doing this. This is, I think, really great work to have a survey, and I think we should continue doing more of these. Right. I mean, using real devices is great, but I think we could also just make sure that the vendors are open with what our current probes are, so that we can. I think it is a cool idea to have just a device that can go around and just try all of them at the same time on the same network. I think that's a really cool approach. I do want to mention one thing if people wanted to test this. There is an API that we have on iOS devices called Hotspot Helper, which allows people who have their own captive portal authentication to kind of interpose themselves during the association phase and be part of the probing. So you could essentially write a research version of that that does a series of probes to kind of analyze these captive portals as we're first connecting to a Wi-Fi and just see what that's like. So if you want pointers on that, we could point you to that.
And I would like to ask you about, like, is there any different point between the iOS strategy or Mac strategy, like MacBook or in the iPhone?
Not fundamentally.
No? It's the same strategy?
From what network probes are done is the same.
Okay, thank you.
Alex Roscoe, Comcast. From my understanding, I think Ripe Atlas probes are adding Wi-Fi to the probe, and it may be interesting to open up discussions with them to see if you can do measurements from their probes, checking some of these metrics. But yeah, it may be helpful because that would be, you get like a global vision of that possibly.
Yes, thank you.
Rick Taylor, Airbus. I really like this. This is all really good stuff. My question is a follow-on is, what affects me with what I'm trying to do at the moment is you discover the captive portal, you log into the captive portal. I'd love to see the survey record what the captive portal is monitoring and how it is building this association. Is it just IP address? Is it MAC? Because I've come across captive portals that will do both. And so if we're building a universal test suite or trying to be universal test suite using all the Android or the Apple approaches, that's great. But can we also try and record what the captive portal is remembering about the session for login purposes?
I hear a volunteer to contribute to the code.
Quite possibly.
Yeah, great.
Yavnir. I don't have any way to get this automatically, but well, we can see that some of the NSPs are actively defeating the captive portal detection. And we have lots of speculation. Do we have any knowledge of why they do these things? Any concrete statements from them why they're doing it?
It's
we have a lot of speculation at this point.
Yeah, I've got several ideas myself, and
I think we've had some of these ideas confirmed, but there are many reasons, I think, from what I've learned.
David Skenazy, jumping in to quickly answer your question. From what we've understood by talking to them, a lot of them don't like the UI that the vendors, and by that I mean the client devices, show when we detect captive portals. So they explicitly go out of their way to defeat our probes to show their own UI by man-in-the-middling all the HTTP traffic.
Hi, Emily Stark, Google. I just wanted to say this is very interesting. I work on Chrome, and Chrome also has its own captive portal detection that it does on some platforms. Did you look at that at all?
It is a Chrome new project?
Yeah.
Yeah, I saw that page.
Okay. Did you consider doing any of this testing for the Chrome detection logic also?
Like, okay, so this time I did not the survey about Chrome detection strategy, but the Android strategy and the Chrome strategy is not the same.
I believe it's different. Yeah,
two different, very.
Yeah, they might use similar. I think Chrome does a probe to one of the URLs that Android tests, but the code is different, and I'm pretty sure they've diverged. I can give you a pointer to the Chrome code offline if that would be helpful.
Yeah, I would like to include that one for my further survey. Thank you.
Well, thanks.
Hi, Jim Reed. Mariko, this is very interesting work.
Thank you.
You mentioned ideas about extending your survey into other locations. Have you any thoughts about how to go about that? Or are you looking for volunteers? Or is there a web page where people get copies of the software or the hardware and try this out for themselves? Or is that still something that's still in a state of flux at the moment? Can you give us some ideas about what you want to do next? I said my name was Jim Reed at the start.
Yeah. So. Jim. And actually, can I
Yeah. What are your plans to? You said you wanted to extend the survey.
For the survey.
Have you any thoughts about how you would go about that, or are you looking for volunteers?
Okay. So my plan for the survey is the most biggest point is I want to survey about other countries, and the other one is I want to include more survey content like the C give me like more survey ideas for Chrome or so. If you have some survey you like to see, please let me know. I want to include more items.
Okay, thanks.
Thank you.
Okay, and now I'm channeling Christian Saunders. At Shaw, we are able to use browser cookies to pre-register devices before they connect to our Wi-Fi network. We need the device browser, not the CNA browser, in order to recover the browser token.
What is the source?
I'm going to cut unless that's quick.
I just wanted to ask for that to be repeated more slowly.
It's in the Jabber room. Okay. So essentially what happens here is that they use the real cookies from the browser to detect previous sessions. So it may be that you're...
Oh, to like fast let you on and bypass. Yeah, I see.
They snoop on your traffic from last time, and yeah. It's kind of clever. All right. So Kyle, thanks, Mariko.
Thank you.
I think we're largely done. Emil?
Yeah.
You sat down.
I have one question. Mariko, does the survey cover mobile devices, or I mean connection with mobile network?
No mobile network.
Okay.
Only public Wi-Fi network in Japan. Yes.
Okay. Do you plan to extend the survey to captive portal situation in the case of mobile connection?
Like I don't know so much about the captive portal in mobile situation.
There are several of them which are very similar with the use case you listed about.
But it is not the same as like the captive portal.
Maybe.
Okay, thank you. So then next.
Okay. Well, I think that's enough on that subject. And Kyle here has a presentation on his draft, which we're all grateful for him writing.
This is on, right? Okay. Hi, everyone. I'm Kyle LaRose from Sandvine, and I'm here to talk about an architecture for captive portal interactions. Next slide. So, I mean, we're all here to learn about captive portals, so we pretty much probably know how they work, what their problems are, but a bit of a summary here. So, they interfere with normal traffic flow when you're first establishing, your login or whatever. They have a habit of modifying HTTP, wreaking havoc on encrypted sessions, and so on. So they just sort of lead to bad behavior. And I mean, there's a draft describing this problem. So if you want to learn more about it, just read that. They do a much better job of summarizing it than I probably ever will. Next slide, please. So, as we all know, there's a working group about this. And from the charter, basically, we're trying to do a few things in this working group. And one was to, make sure that devices can figure out what URI to go to interact with the captive portal. And, detect the captive portal in a consistent manner, learn about it, deal with it, and, even better, if necessary, to do it without any human interaction, which enables a bunch of use cases that would otherwise be impossible. And we had a lot of discussions about this on the mailing list in meetings. And so what me and Dave tried to do with the architecture was condense all of that down into one document that describes sort of how this should all work together. Next slide, please. So, again, the main goals of the architecture is to provide a standard way to implement captive portals, or a set of ways maybe. Maybe there's a few pieces that could vary or work one without the others, but the key point is that there's a few components that have a well-defined set of behavior, and the architect is calling those out and trying to say what they need to do and what they maybe could do optionally. Next slide, please. So there's the architecture. It's maybe the text diagram that I had in the draft was actually better than this, but I tried to make it a little more readable here. Sort of draw out the four main components there that are all interacting, and in the further follow-on slides, I'll discuss a bit more what they do. But essentially, the arrows show the flow of information in the system. Next slide, please. So the user equipment, it's your handheld device, your laptop, some light bulb somewhere. It's a thing that needs to get access to the network. It interacts with the DHCP client. It's a client. Sorry, it is a client of DHCP or maybe something else, but that's how it gets the URI. It's a client of the Captive Portal API. It might have a human, and it understands this, the new set of ICMP messages that we've been thinking about introducing. And one thing I want to make clear is that with this architecture, we don't want to specify the UI. That's really up to the user equipment, because that interaction, different devices might want to do it differently for various reasons. Next slide, please. The DHCP server, maybe the router, it implements RFC 7710, which basically the intention there is to give the user equipment the URI with which to interact with the Captive Portal. I think it initially was not intended to be a generic API. I don't want to speak for the author, but that was my impression. But because it was just a generic URI, that means we can actually implement an API at it and have it be a little more extensible. I think in the draft that I put up, I may have been a little too strict about calling it a DHCP server. I think it's really just, there's a component in the network that can give you access to the URI somehow automatically, and that's its main role. Next slide, please. So the Captive Portal API server, there's going to be a talk after this talking about it, so I won't say too much about it, but basically it's the thing that the client interacts with to gain access to the wider network. So traditionally it would be the web server providing the browser where you click OK, yes, I accept the terms of service, or enter your login credentials. But it could also be some sort of generic REST API that would allow you to do things automatically now. Next slide. So the Captive Portal enforcement, this is a fancy way of saying the thing that's blocking you. So, it could be the Wi-Fi hotspot, it could be a router, it could be, something in the mobile network. But it is responsible for enforcing the policy, the Captive Portal policy, and informing the user when they don't have access, or they're about to lose access, or a few other things. And I'll get to that in a second. One other key point is that you may allow access to a walled garden, which you might need to just get more information about the network, or maybe there's some free stuff you can do. So it's worth calling that out. Next slide, please. So the ICMP Unreachable message. This is an extension to the ICMP Unreachable message, which indicates that you're behind a Captive Portal. There was a draft about it. It expired. I think it's being revived by David Bird. And the intention there is to inform the user that there's a problem with it, them having to poll the API server to, and even more further, the new version of the draft is calling out an entirely new ICMP message type, which can give more sort of graceful interactions after your Captive Portal has been established. So maybe it'll alert you to quality of service issues or a pending expiry or things like that. I found out this during the hackathon, and it was kind of cool to play around with. So there's some security concerns that were mentioned on the mailing list, and I think we still need to hammer those out. So one option was to use a token for authentication, but we need to figure out how to actually get that. right, next slide, please. All right, so this is kind of the workflow for someone who's using a web browser to log in. I probably need to change the wording in the document. I don't want to call this out as being the only workflow. It's more of an example workflow of how we would actually do things. But the idea is the user turns on his phone, connects to the network, interacts with the DHCP server. DHCP server gives an IP, and it says, hey, you're behind a captive portal. Here's the URI to interact with it. The user then goes to this URI and attempts to log in. Login succeeds, and sort of in parallel, the API server tells the captive portal enforcement to let that user through, and then the user starts interacting with the external network. Sometime later, the user, his session expires, and the API server tells the captive portal enforcement device to block that user, and then an ICMP message is generated and sent to the user, which forces them to, pops up something on their, like their network monitor thing saying, hey, you're on a captive portal, you need to log in again. That's the point of the ICMP message there. So there's some options here. Maybe the user just tries to connect to the internet, sort of assumes there's no captive portal, and the ICMP message would tell it that there is one. And if they happen to access something behind the walled garden, they don't even need to log in. That's why I said this isn't really the only way of doing it. So I think there's some options there. Next slide. This is pretty much exactly the same with some sort of Internet of Things device. The only difference is there's not a stick figure there. The user equipment basically automatically does the login, whereas before somebody would have hit a button. Next slide, please. All right, so security concerns. Is the token approach efficient for ICMP validation? Are we going to have trouble getting the token? The concern here for those who haven't been following the mailing list is some random bad actor on the internet sending in one of these ICMP unreachable messages to handhelds and stuff, and just generally DOSing them or wreaking havoc on them. If we're doing more than just closing connections, maybe it'll drain their battery or worse or something if it pops up or causes a bunch of pop-ups. Other questions is, do we need to authenticate the server API? The API server, sorry. One concern I had is something like someone driving around with an open access point and just having people connect to it and then authenticate themselves and trust that connection, start sending their plain text internet traffic through it or something. Maybe there's something that has to happen there too, particularly for the automatic logins, to make sure that they only log in where they're supposed to. And I think I've heard talk that there's, Hotspot 2.0 is going to solve that problem, so maybe it's not a big deal. But we should talk about it. Anyway, so talking about concerns, there's also some positive sides to it. So getting rid of the redirect, the DNS poisoning, all that, there's no longer a man in the middle. When we're explicitly saying how to interact with things, or we're explicitly saying there's something to do, the user, it just cleans things up. It makes it explicit. It makes it sort of above ground, and everyone can play nicely together. As we just saw, there's a whole bunch of ways of doing this, and people seem to want to try and defeat it. Not sure if this will make them not do that, but hopefully, if there's if all the client devices start implementing these simple, easy ways to authenticate, there will be some push for the captive portal vendors to actually adhere to the standard. And another security benefit is the portal is restricted to what DHCP server or router advertisement or whatever said. So you can't just go off somewhere else. You're probably going to be attached to a well-known device to get your login and give them your credentials. Next slide.
Just a reminder, we need to move along a little bit.
Okay. So I have a bunch of unanswered questions. I think some stuff I think we need to answer on the working group to move this document forward. I guess I'll mostly skip these, and we can always talk about them in the mailing list itself. So next slide. All right, so next steps. So what do we want to do with it? And do we want to keep working on it? Is it a waste of time? I hope not. I'd like to see it move forward. I don't know if the working group should adopt it now or if it's too early. What do you think?
Well, from my perspective, I'd like to see a little more discussion about this and a little more feedback, and probably some of the architectural questions need to be explored in a little more detail before I think we want to actually ask the room whether this is something we want to work on, but it's certainly promising.
Right.
But that's largely a personal opinion because I've not seen a lot of discussion yet, so I'd like to see that.
I agree with you, honestly. So I think that's pretty much the end of the presentation, so let's take questions.
Well, stay there and answer a few questions. Let's try to keep this short.
Well, I
don't know who was first.
By the way, I was first.
Go on.
So I don't think it's a goal to get rid of the redirect. We're going to have to do that until the end of time anyway. So that doesn't seem to be a goal. I wish we had something better to do than the ICMP method. It seems like really messy. It gets rate limited. It's to some degree subject to forging. It's sort of be better if we had something else. One thing that I think we discussed this in, forget what, at least 2 ITFs ago maybe. If the captive portal is time-based, just tell the device how long it's got left on the clock. And so you don't have to rely on the ICMP message. If it's a 24-hour thing, just say, hey, in 24, your login is good for 24 hours. And if you want to check periodically, here's the URL. Yeah. And then you kind of don't need the ICMP messages at all, really, because you can, as soon as the device says, oh, this thing is not working, you can just check the URL again.
Well, I think most of the components actually provide benefit on their own. So just the API server could help. Just the DHCP extensions can help. And you could even get something with just the ICMP messages. So I think we need to iterate a bit more on the architecture to figure out what's actually necessary and talk about what the benefits of each of the components are. And maybe those will help give some follow-on drafts to talk about recommendations and methods of building real systems.
Margaret Cullen, Painless Security. I think you were right that it should have a little bit more in there about both the DHCP and the RA option, both of which are in 7710. That's just editorial, really. I agree with what Lorenzo said about the ICMP messages. I'd like to add, one is that I see some fear that these ICMP messages could be used to shut down nodes in cases where there isn't even a captive portal. Okay? The other is that if you're going to implement a new spec, I think we probably want them to implement a new spec that actually goes in and navigates the portal well. You say like the ICMP messages add something on their own, but there was a previous draft for it that apparently didn't have enough traction to think it would add on its own, right? And I think it raises a potential attack, and I don't think it helps that much.
Well, we had some pretty good discussions during the hackathon about what the ICMP messages could give you. And maybe you could do it without it, but David's working on the new version of the draft, and I think it's worth discussing the draft a bit more, the one he's working on, because it does extend the ICMP concept quite a bit, and maybe
maybe the people who had ideas at the hackathon about how it could help could either jump up or write them to the list or something, so the rest of us could see that and have an opinion. We could have some list discussion.
I'll summarize a few of them later, I think, in my hackathon presentation. And I think that those who did have the ideas, definitely please post them to the list, because that will generate discussion, foster that sort of thing.
Yeah, without further implementation, though, they won't do anything. Somebody has to implement those ICMP messages.
Just use my hackathon thing. It's
No, I understand that, but what I don't understand is if you're going to go in and you're going to put new code in, don't we want them to put new code in that can actually do more than that? That's my concern.
I guess which is the most important to do up front.
Okay, in the middle.
Pierre Pister. So in the previous presentation, there was a few details about the different behaviors that are currently implemented in the devices. As far as I understood this proposal, this is not backward compatible with existing devices. So this may be fine, okay, but if you think there is strong reasons why the proposals from the working group should not be compatible with existing devices, it must be argumented very strongly.
I think the CAPPORT API talks about backwards compatibility. So if you go to that server, and so you would read, suppose you were behind a CAPPORT portal and they didn't really support anything other than the redirect, then it would redirect you to that API and it would just serve up the old browser style web page.
Yeah.
Pardon?
Yeah, the problem is when you first create a new connection, you get an ICMP unreachable, and devices may just bail, like, what? Okay, what should I do? Nothing, probably.
Well, is that any worse than like what happens to HTTPS right now?
Good point. It would not even work with HTTP.
We're going to cut the lines here, I think. So.
Okay, Yavnir. Well, the baseline is what we described in the previous slides, and this is, I think, what you're proposing here is considerably less clunky than what we're doing today, so it's kind of a good thing. The thing is, what we have today kind of works mostly, and where it doesn't work is where the people who put up the portal are actively defeating it. And because we sort of, at least partially, understand why they're doing it, I don't see how that solves their issues. I mean, why wouldn't they want to defeat this thing as much as they're defeating the things that already exist?
Yeah, that's one concern I had. So I think we would need to make a compelling argument that it solves those problems and find out what those problems are to make a difference.
Yeah. Hi, this is David Bird. Just a comment about the ICMP. So the idea is that an AS right today only has a few options when it has traffic that it doesn't want to let through. It can either just black hole it. If it's TCP, you can give it a reset, or it can give it a destination unreachable. The idea of the CAPPORT ICMP extension is just to give the user equipment a little bit more information. So instead of just giving it a destination unreachable and then assuming it's not accessible, this actually indicates it's behind the CAPPORT portal. So it gives us a little bit extra information about why your packet was dropped. And I don't see where that would be any additional security considerations above destination unreachable on ICMP.
You'd be surprised.
It's Chris Seal from Hutchison. Speaking from a mobile operator's perspective, the only issue I have is on the DHCP RA side. I don't think I've got a way of issuing a URI as well as the IP address, because mobile networks in PDP contexts, they provide you with the IP address, but there's no extra field that I'm aware of.
There is a I'm not sure if the next talk can help with that. Does Tommy, do you know if the question was, in mobile, how do you get the URI to the handheld device if you don't have a DHCP server, for example?
I suggest you talk to someone who's more familiar with the configuration architecture of those networks.
I'm pretty familiar.
Yeah. If there is no field,
yeah,
and you're doing v4, assuming that you're doing v6, I assume that the
most of them are still doing v4 because it's usually private IP address ranges.
Right.
But I mean, my point is, I think it's a great solution because I mean, the only use I have for this is prepaid customers that have run out of credit, and they either get a nice message on a page saying, "Please repay," or if they get nothing, they'll be calling the call center. We'd much prefer the former.
Yeah. So maybe those people can have the URL printed somewhere for them.
Maybe. I mean, I'm just making aware that we need a slightly wider.
It's a good
ideally, we'd have a wider solution.
Hi, it's David Olson. co-author on this draft. The questions of the ICMP, we did give some thought to it. Like, I think some of the concerns are, could an off-path attacker send ICMP packets to try to disrupt random people? The way I was thinking about that was compared to, currently you could try to do that. But, in this case, we think, unlike the 307 or 302 redirect, the URL is not coming in that message. So on the one hand, the worst you can do is make the user go to the portal URL. You can't make them go to an arbitrary URL. And to mitigate, that, well, then you could say maybe we could, DOS that URL with by reflection. But then that's what we were thinking about. Kyle mentioned the token or something. If you could put something in there that was hard to guess, you could make it, at least as hard as killing a session with a TCP reset or something. So, that's the thought and discussion on fixing it in ways like that is how we were thinking of it. So we think it's better than current.
If you're really quick.
Yeah, I wanted to make one last comment about that, and that was perhaps we could also require, when processing this ICMP message, that we actually validate that some part of the message that it's responding to is there, right? So you had to be an on-path attacker because the captive portal device must effectively be on path.
Right. I believe that the ICMP unreachable message quotes the original packet. Right?
Not very much.
But it's kind of, yeah.
There's not a lot of entropy in there, I'm afraid. So you need to be aware of that.
True. Yeah.
It's very, very, very small.
You could guess.
Certainly in v4. I think I'm going to cut this one though.
Thanks.
And Tommy's going to talk briefly about provisioning domains.
Hello, everyone. I'm Tommy Pauly from Apple. I'm a co-author with a bunch of other friendly people from Cisco on a draft for doing provisioning domains. And what I want to highlight here is not the whole draft, but specifically the part of it that applies to captive portals. Next. Okay, so what are provisioning domains? Not everyone knows what they are, unless you've gone to MIF. Next one. So it's defined in RFC 7556, which is a MIF document. Essentially, a PVD is a self-consistent set of configuration information that a host can use. So this is your addresses, your DNS. How can I actually effectively use one particular network connectivity? Next slide. So there are two conceptual ways of getting these things. One is through implicit discovery, and that's essentially what everyone does now. You get provisioned things by DHCP, you get stuff through RAs. Some things you know just because I'm connected to a Wi-Fi. I know it's Wi-Fi. I know it's cell. VPNs have their own whole set of configuration that comes down. All of these configure what a device can consider a PVD. It also includes DNS attributes. So these are great, but the holes that we have are when you potentially have multiple PVD uplinks from what looks to you like a single interface. So I have a Wi-Fi router that actually gives me access to multiple networks. That's very applicable in like the home net cases. So in those cases, I am blind to those other PVDs that may be there. But then there's also the case in which there are properties about the PVD I'm associated to, like it's captive, and I'm also blind to those attributes. And effectively, I want those to be part of my PVD. And sometimes, essentially like, an Apple device, an Android device, we can kind of infer that, oh yeah, I did this probe, it's captive, and we just guess, and we put that into the PVD information, but it's not explicit. Next slide. So a lot of what this draft is about is saying, can we finally have a way to explicitly define new PVDs and what the PVD attributes are? So this is required to use multiple PVDs on a single interface. The draft goes into how you can have essentially a PVD for each IPv6 prefix. The PVDs are given out by different RAs, and the RAs have a PVD ID, which is an FQDN inside of it. But we can also use that to convey extended attributes. So what are the captivity or limited access walled garden attributes, cost requirements, what type of quality should you expect, what's the timeout. So this list could grow and grow and grow, and it's not really clear how much is appropriate to have in here, but we wanted to get the conversation started. Next slide. Okay, so we've been talking about this for a while. We're also very interested in captive portal. We see the conversations going very much in the same place of, oh, we need to know we're on this type of network, and then we need to contact something to get more information and interact with it. It's like, this is very parallel. So my main goal of presenting this is saying, can we make sure we don't go down two different paths? Is there a way that we can have a kind of coherent story that gets the captive portal benefits, and we can actually convince captive portal vendors to implement this, and also get Cisco routers and HomeNet routers to implement the same thing? Next slide. Okay, so in this draft just takes a stab at proposing, here's one way we think we could do it. So it says that the PVD is identified by a fully qualified domain name. In the draft, it comes down through an RA. It could come from something else. It can come from your VPN. Your carrier could provision in the same way that it provisions the addresses. We don't care how it gets pushed down. Next slide. Cool. And then you would want to be able to, if you have other metadata, go out and query that. In the draft, it says, go do an HTTPS connection to some JSON file that's based on your PVD ID. This is very nascent. It needs to be expanded upon. But I think it'd be good to see, does this API look similar to what we're about to hear about from the Captive Portal API? Can those end up being a similar mechanism, or does this blob then point you to the REST API? Is it on the same server? Is it a different thing you can interact with? Next slide. So here are just a subset of the properties that were listed in the draft. It lists a bunch of options based on presentation earlier. I'm sure we need to call a lot of them out. I imagine that we'll probably want to split up the draft into, like, here's the ID and here's how you discover where to talk to, and then we can extend what you can talk to. But basic parts, it has to have a name. It says, what are your prefixes? Do you have internet? Is it a captive portal? If it is, what's the API I can use to interact with it? This could allow us to potentially have different versions of how we interact with captive portals, et cetera, et cetera. Timeouts, when should you next check in with me? That's a way of potentially avoiding the ICMP route. Okay, so just to summarize, these problem areas look very similar. The PVD area is, I just think, the generalized form of the captive portal problem. So please give your feedback on that. Let's see if we can have cohesive solutions. Just kind of thinking about the structures that incentivize people to do something or not. If there are ways in which, we say enterprises and other groups want to start deploying PVDs because that allows the end devices to get new cool interactions and new features, are there goodies that we can toss in there that will incentivize them to adopt these models, and then, oh look, we also happen to know they're captive at the same time? Of course, we won't get all the malicious people who want to just trick us through, but at least the cutting edge devices would work better with this new book. So any feedback would be appreciated.
I'm going to suggest that this one requires a little bit of thinking. Thanks for doing the presentation, but
read the draft.
Read the draft. Think about how this is going to fit in with what the various people who have architectures and protocols in mind. Think about how that's going to fit in, because this seems very close. You're right.
Yes.
David Bird. The API or the URL that you pointed to, do you picture that on the NAS or on the web server?
Yes.
Yes. This is
either one.
Yes, either. It's open to discussion.
Well, I'd offer that on the NAS, you'd need a certificate per device.
Right. That's possible.
So that's costly.
Yeah, I think it could be much further up, potentially in some cases, in which let's say I'm just discovering information. about my PVD, which is just like I'm on GoGo in flight or it's Comcast, and it just takes me to some like master server that's kind of behind everything.
Yeah, Eric, I think the device would just have to let that through, right? You know, HTTPS to with an SNI of, oh Lord, SNI of that name would have to just be allowed through. Yeah. If this were part and parcel.
Or you whitelist the IP or whatever you think is necessary.
Oh yeah. I think I'm a fan of PVDs. I do think that there's more information in here than certain things belong in certain places, and there's sometimes some of this stuff seems to be like we may have two places to do things. I think when it comes to like expressing charging information and that kind of stuff, I would rather presume that the device that's actually blocking me is the thing that would know what my charging is, not necessarily the PVD, and so we could leave that to the REST API to talk to the device. And then what do I do if I have RFC's 7710 URL and a PVD capture portal URL and they're not the same?
Right. Yep. That needs to be reconciled. Right. A lot of these attributes, maybe they don't belong directly in the PVD, but I imagine when we store them, we will store them somehow in associate, like this thing is associated and is at least scoped to within this PVD, potentially. So.
Forensic. I think actually I think this is great, and I think for two reasons. First of all, it might work, and second, I honestly don't know if it will work. But I think even if it doesn't work, the PVD general infrastructure will be so much the richer for having tackled this challenging problem. Right. In the sense that here, if you try to solve the captive portal problem with this, you will have to build updatability, maybe scopes or whatever, all this stuff, right? It really needs to be in there. For example, how do you check, what do you do when the captive portal goes from closed to open because you logged in, right? How do you do you give it a different PVD ID? Do you change the URL? What do you do, right? And so it'll be very, very interesting, and I think this is it's going to be a great exercise. Another point that I wanted to make is a meta point for the whole. We've gone over this, I think, many times. From my personal perspective, it is not ever, should not ever be a goal for this group to work on, to optimize for the case where an operator is trying to defeat the portal, right? Because there's just no point in that, right? If that's what they want to do, it's a business reason, and we can get into an arms race, but that's not something that's, and some of us might, and some of us might not. But that's not something that we need to worry about here, because it's going to be inherently very hard to. It's going to be a moving target. There's no point in talking about this. So let's not try to do this for sort of malicious cases or let's say conflicts of interest. Let's just do this for participating parties. That means our API doesn't have to be quite as paranoid as you might need if you're trying to address a conflict.
Yeah. Right, and just one thing to that point is you're saying also that this is a good problem for us to solve and think through in our PVD architecture. The best case scenario is this just moves us forward into a world in which we don't think of them as captive portals. It's just devices that can interact more closely with their network and are more network and path aware. And maybe they have interactions that are similar to what captive portals do, but they eventually evolve beyond that hard wall.
Yep, lines are cut, by the way.
I suppose if you basically move beyond the captive portal to something that just tries to enforce a policy. I mean, a lot of the time they're just trying to talk to the user. So this is not going to help, right? They're trying to get someone to click on a button to say they agree. And, you can just know that, but you can't agree yourself, right? You have to get the user to agree.
David Bergen. My concern about the provisional domain information being not on a NAS is that it gives a lot of opportunity for misconfiguration. People configuring your APs are not the same people, setting up or configuring your portal.
I'd like to push back on what you said before, because true, we can't win the arms race. Somebody who owns the network, they can block the network for you. But if we understand why they're doing what they're doing, then if they need access to the regular browser cookies, well, they want the regular browser cookies. They want the regular browser. We can provide that, or we can decide that we don't want to play with them and get the thing shut down. I know that I have a place, with a captive portal that I need to enter a username and password, and I get the phone dialog, and I just dismiss it because I want to get it in the regular browser, because the regular browser remembers all my username and password, and it's much easier that way. But, we really have to understand why they want these things.
Yeah. So just to respond to that before I sit down, I think I agree that just doing a survey of this, like what we had before of a survey of what are the interactions, what are the surveys of why people avoid going through the captive portal is very useful as a design consideration. But I think the solution to that long term, if there is one, is not going to be a protocol one. It's going to be one for the vendors to change their UI, to change how they interact with these things, to either give people what they want or convince them they don't want it. But that's, I think solving the problem in the protocol aspect is not for this group.
Okay, where's Mark?
All right.
You have 10 minutes, I'm sorry, but you'll have to be a little quick. I noticed how many slides you have.
Quick it is, okay.
Yeah.
We put together a proposal for a captive portal protocol so that the devices that speak it can get access to the captive portal. Next. First thing that the first bit of feedback was that people wanted to see examples of what the protocol would look like. So here's a walkthrough. Starts with URL acquisition. Starts with CAPPORT API URL is obtained from DHCP or IPv6 RA through RFC 7710. User equipment, if the user equipment doesn't support the protocol, it just throws a web browser request. If it does support the protocol, it starts a JSON session. Next. User equipment initiates the conversation. Posts data, sample JSON here with empty networks and empty session token. This just gets the conversation started. The CAPPORT API server responds with available networks, requirements, so on and so forth. It may have multiple networks that it deals with. It can advertise all of the networks that it has available. Default, I declare it to be a convention that if the user equipment doesn't know what they want, it doesn't necessarily know anything about these, it should just choose the default. It kind of intrinsically has internet access if by convention. Next. The user equipment attempts to satisfy the requirements of the API server. Actually, could we go back one real quick? Down at the bottom, you'll see you have in the JSON you have a set of conditions. That's an array of JSON objects, hashes with an ID, a type. Each condition has an ID, each condition has a type, and requirement details that are specific to that type. And down at the bottom, we have the state of current network access being not permitted. So forward again. The user equipment attempts to satisfy the conditions. We regurgitate the ID that we're attempting to satisfy, and we give back the satisfaction details. In this case, the previous one had been the terms and conditions, and the satisfaction is giving back an MD5 sum to prove that we've looked at them. The last two steps can repeat as needed. For instance, if a user equipment doesn't want to satisfy all of them at once, if they can only do two first of the 5, it can go through with the 2. The captive portal API server responds with the same sort of JSON from the last step. It's just leaves out all of the conditions that are satisfied and transmit or communicates only the conditions that have yet to be satisfied. Or the CAPPORT API server might decide that it has reason to add requirements on as it goes through and satisfies as the user equipment satisfies different conditions that may trigger follow-on conditions. Next. And then finally, we grant access. This one, the network, we don't have any conditions left in this. The state is permitted. We have potentially an expiration date or the number of bytes remaining. Next. So the conditions. Each network has an array of conditions for access. As I said, each condition has an ID. I was thinking of a UUID for that, a type, and then details of the condition requirements. Draft currently defines a type for passcodes and for terms and conditions. Margaret, my co-author, pointed out that we should really have one for go get this URL as one of the conditions, but we definitely need more. The idea here was that this would be extensible. If we do this, probably want to get an IANA registry for additional condition types. If the user equipment cannot satisfy the conditions on its own, it should open up a web browser to the CAPPORT server URL as a web browser and just give up on the CAPPORT protocol. Questions I had on this, do we actually need to return any errors in the conditions if we attempt to satisfy a condition and it fails? Should we return an error? Would that be useful, or would the fact that the condition comes back be sufficient for the user equipment to infer that? And do we need a way to express complex logic, like at least 2 of these 5? Next, terms and conditions. Type T and C, requirement details. You can have a field named plain text or a field named HTML that just give the verbiage of the terms and condition. The satisfaction details, you just take the MD5 sum of what you were given as a way to prove that you've done some sort of inspection on it. I don't know if MD5 is the best way to go here. The draft says that on satisfaction you can do an MD5 sum of the plain text or the HTML or both. I was wondering if both is just opening up the potential for people to get it wrong. Like what happens if only one of them is right? Next, passcode. The idea here is the hotel that gives you your room number and a passcode, the Wi-Fi password. The requirement details, the type is passcode. The requirement details is just an empty JSON hash, and the satisfaction details, you say passcode with the value of whatever they give you. Next, sessions. This was, I think, one of the big differences, one of the major points that Dave Dolson's response to mine to this document had different. Was that he had a call explicitly to create a session, whereas my draft was written using the assumption that the CAPPORT API server would just use the source address as the session, figuring that since it's the network equipment, it would know. Another option would be that the CAPPORT API URL could be the DHCP RA URL could be different for each user equipment, and that could effectively be a session. The draft would definitely benefit from examples here. And that's the end of it.
Okay, questions? I'm going to start with a bit of a comment. No chair hat. I observed that you are designing a protocol that's very much like the ACME protocol in some respects, without some of the security requirements, with some perhaps different characteristics, but it's very similar in the essential design. I'd encourage you to go and look at that document.
I will.
From an HTTP perspective, it is a much cleaner design than what you have here. Obviously, what you've got is rough, drafty in the very first version, but they have some significant improvements over what you have here in various ways. They've also grappled with some of the questions that you're asking. So it might pay to even go and have a look at older versions and see why they removed those things. And you can find the authors of that document here this week, and I'm sure they'd be happy to help you.
Thank you.
Alex Roscoe, Comcast. So the RA and DHCP options, I think to provide backwards compatibility on the API, I think it'd be interesting to use the 302, the URL and the 302 redirect. So if, for example, captive portals are real easy to change and update, while routers to provide the DHCP and RA option may come later. So you could decouple those two things together. So a device could check the 302 redirect URL, maybe hit it with like a JSON request, are you an API endpoint? And if so,
Alex, if you follow HTTP, if there is a redirect in place, this request for the JSON will go to wherever the redirect is pointing. So that's not actually a concern.
Okay.
Hi, Jim Reed. It seems a bit odd to me that you're using MD5 or suggesting MD5 when lots of the crypto community are actually saying don't use it anymore. It's almost tainted. So I wonder maybe we need to think about having some mechanism for accommodating a variety of different secure hash algorithms and be able to have the flexibility to then switch, say, from SHA-1 to SHA-2 or whatever, as and when the need arises. I mean, I don't think the actual values of the hash is really all that significant in this particular context, but it does look kind of bad that you're suggesting MD5 when the rest of the world is saying don't use it anymore.
Yeah, I would prefer that this be, we talk about the macro level concepts before we talk about that, but certainly anything with MD5 in it is going to raise all sorts of red flags.
Yeah, I mean, there's very little difference between putting an MD5 checksum in here and putting a yes in here in terms of what this protocol is doing, because there's essentially no way to prove to the portal that you displayed text to the user. Okay, they just have to take your word for it. They take the browser's word for it.
One thought that I had was that if the user equipment decides to store the terms and conditions text, it could preemptively put forth when it tries to connect to the network that I agree to these terms and conditions, and if the terms and conditions have changed, then the MD5 would fail, whereas the yes would not.
Yeah, but we'll be happy to globally replace MD5 with whatever Jim tells us is a good hash right now.
Quite happy to.
Eric Klein. Yeah, well, you can find 6331, I think, for SASL deprecating MD5. But I think I wanted to ask you about one of the places I got lost in the document was the networks, and then a subset. If underneath networks, there's a set of networks, and one of them is called defaults. And I didn't understand what the purpose of having. I got lost in the purpose of having multiple networks and not just the one.
Purpose there is if the captive portal has multiple networks that it guards, multiple protected networks. If you have if you have a captive portal in your office, corporate environments that has that walls off guest access, that gets you access to the internet only versus corporate access, if you have the right username and password to get into it, that's one of the thoughts that I'd had there.
So the idea is that this should be presented to the client, though? The client should be allowed to, like, say, I'm on this VLAN, or I'm on whatever network I'm on, whatever SSID I'm attached to, and I want to select to be routed to guest or to corp or to lab or something?
Yeah.
Or, I mean, the other one is when a hotel will give you free access if you just provide your name and room number, but they'll give you high-speed access if you provide payment information. And yes, I mean, I guess part of the UI would be either like an IoT device that just wants limited access might just take whatever's cheapest, but I would think on your phone or whatever, you'd want to pick whether you're taking the slow non-pay or the higher cost fast network. And I don't know how we can make that decision for you. So yeah, I think it would have to be in the UI.
It's all the same L2, L3 infrastructure, just like different parameters on top. I see. Thanks.
Tommy Polly, Apple. To that point, I also find the hierarchy of networks potentially a little confusing. It also seems to like maybe overlap with PVDs. I don't know. But I can see like from, I think like a VPN, I say who I am, I authenticate to you, and based on the authentication I choose and we negotiate between us, you may put me in a different group and give me different access. So if we just have like authentication options of like, well, or like here's the things I'm willing to give you, and then based on that I get dumped into a different access bucket on the captive portal. So if I have the admin credentials, I go to that, but the average user who has just the room number doesn't need to know, ooh, there's this admin thing. I can try to poke it and see what it does.
So just to comment on that as well, so that's on the multiple networks. That's something that we're trying to solve with the PVDs, and that's something that is more general than just captive portals. The fact that even on a single link, you may have multiple ways of accessing to the network. So it would be maybe not the best idea to solve the same problem twice. So I think the right way to do it is in the network layer, so using arrays, and not as part of the captive portal API. So if you want to have multiple captive portals, virtual captive portals, you can provide multiple PVDs using IPv6 proposal, and then do having multiple captive portals. I think that would be a simpler option than having two layers with twice multiple networks.
Thank you.
And so we're almost done as well on the time. Kyle, did you have any very short summary that you want to share? The slides are up here. Kyle was going to present, time permitting, but we were having such a good discussion on the other things. I think it was probably time better spent on those. Just spend a couple of minutes and sort of explain what you did. So this is the hackathon on Saturday and Sunday.
Yeah,
Kyle
so
organized this.
A bunch of people in this room actually were at the hackathon working on this. So essentially we had a couple of laptops wired together, and we put together an API server and put some ICMP stuff in the client, some ICMP stuff in the captive portal, and made it so that when you connect, you pretty much, the instant you try to do something, you automatically log in and then you have network access. So we implemented the ICMP on the client and on the captive portal. We implemented something kind of like the captive portal API that's described in the draft, but not quite on the server itself. Sorry, on the captive portal enforcement device itself. We did some TCP dump and Wireshark work to dissect the captive portal ICMP enhancements, and I think we also ended up implementing the DHCP server side stuff, but never got around to really testing it because the client side stuff wasn't done. But it worked, and it was actually not that hard to do. Raw sockets made it pretty easy to do in Linux. It's not perfect, but it's a pretty good proof of concept, and we could probably keep moving it forward to test out and prototype new versions to the various drafts. And I think it would be neat to sort of have that ongoing outside of the hackathons. That's pretty much it.
Thanks, Carl. And thanks, everyone. Has everyone signed the blue sheets? I have a copy down here. But this meeting is adjourned. Thank you. Roadrunner. Excellent. Thanks, Dan.